Namaste all. My name is Neha Verma. I am assistant professor in Medi-Caps University Indore in the Department of Electrical Engineering. And today I am going to give a presentation on fundamentals of electricity. We are utilizing electricity in various forms. We are utilizing electricity in the form of luminance. We are utilizing electricity in the form of heat. We are utilizing electricity to exchange the information. So basically, we can define electricity as the form of energy which can be realized into other forms of energy using a particular setup, which is the combination of different components. Electricity is the energy which we are utilizing in our daily to daily life to accomplish our work. And now we will talk about the what is electrical system and some basic fundamentals of electric energy. So when we talk about an electrical system, there are four units associated with it. First unit is representing the production section, in which we produce electricity. And for the production or generation of electricity, we are utilizing the energy of various sources. So basically, if you are using chemical energy of battery to operate your mobile phone, then it is also a source of energy. And if you are utilizing the hydral energy, or we can say kinetic or potential energy of water, and generating electricity with the help of it, then it is also a source of energy. So basically, in the production section, we generate electricity using the energy source, and the source could be uh, a renewable one or a non-renewable one. So it is a broad topic we discuss in the later sections. So now we will discuss the second section, that is the transmission of electricity. As we know, we have generated or produced electricity at one point, and we have to utilize it throughout the world. So we have to transmit that produced electricity from that generating end to the several points of the areas. So its transmission system is used for this purpose. So various set of cables, wires, poles, structure, etc. are used to build up a transmission network. And before coming to the third unit of controlling of electrical system, we will discuss the application. So basically, a set of equipment which is utilizing electricity and make our task easier is called an electrical application. Anything, any machinery, any appliances which are using electricity as an input and doing some work, like while it is uh, making our food or grinding something in the mixer grinder. All of these things are the applications of the electricity. And at each point of these three, that is production, transmission, and application of electrical energy, control system has its own importance, because uh, the control setup is only the part which ensure the safety of human being. Electricity is a good friend, but it could be a great enemy if you uh, if you don't take precaution while dealing with it. Okay, so now let's take a small example to understand these four units of a simple electrical system. Here, this is a one room. Here, a number of loads are connected, like a lamp is connected, or a fan is connected, or a TV is here. So, the source, or we can say a simple example of a rented apartment, where where the source of energy is that energy meter from where the electricity is coming to our house. Okay, so that will work as a source, and this electricity is provided from this energy meter to other points of application through wires. So in that case, the wires are worked as a transmission unit, And the appliances which we are used to utilize the electricity, like lamp, fan, cooler, etc., are comes under the application part. And the switches which are used to turn off and turn on the electric appliances will work as a control unit. So in this, with this small example, we can understand the importance of these elements of electricity. Now, uh, this is all about an electrical system. Now we will go with the core or the fundamentals of electricity. So firstly, we have to discuss the charge, because electricity is nothing but the energy obtained from the flowing charges. So firstly, we all have to know that what is charge. So basically, uh, in the whole universe, each matter is made of molecules, and these molecules are arranged with the specific chemical structure, and the chemical structures of these molecules will define the property of any material. And if we go to the least entity of these molecules, and it will be an atom. And this atom basically is the core part of each matter existing in this world. So let's discuss the structure of an atom. So basically, atom to understand this structure, the most common example we can take is that the relation between sun and earth. As we all know that the earth is revolves around its axis, as well as it's revolve around the sun. In the similar manner, atom has a nucleus, and nucleus has two type of element. One are called neutrons, which are neutral particles of the atom, which are not positive, neither they are negative. And one more type of particle present in the atom are the protons. Protons are positively charged particles, and the number of protons present in the atom atom's nucleus, the same number of electrons revolve around the atom's nucleus, uh, on their periphery, in a particular periphery, as well as uh, on their own axis. So thus the complete structure of atom can be represented. So this exchange of electron from one matter to another matter will define the flow of charges. If any atom accept electron within its body, it will be represented as an acceptor, and it is negatively charged because it is accepting, it is receiving, so it is negatively charged. And if any atom donate its electron to other matter particle, so it will donated the electrons, so it will positively charged molecule. So in this way, positive and negatively charged particle exist in this universe, and due to this flow of charges from one to another and from another to rest of the particle, the flow of charges can happen, and thus the electric charges uh, form the electricity. So we can define the electric current as the rate of flow of charges with respect to time is called current. Or in other word, we can say the flow of charges in a closed path, because the flow of charges is possible when the charges have a path, a complete path. It has starting point, and then the charges start from that point, and they come back to this point and finish their uh, traveling. So current the flow of charges are it could be possible only in case of when the path is closed. So we can define current as the flow of charges in a closed path with respect to time. So this is nothing but is called the electric current. So To understand the concept of flow of charges, let's let's take an example. Suppose we have two containers, and these containers connected through a pipe, and let's suppose this container is full of fluid, or say the fluid is water. So this container is full, and the next container is empty. So as we connect these two containers through a pipe and we turn on the tap, so we will see that the water will starts to flow from this full container to this empty container. This is happen because this container has high potential and high potential of water, while this container has comparatively low potential. So the water will flow from high to low potential. In the similar manner, uh, the electric charges always flow from a point which has high potential and comes to a point where the potential is low. So the high potential is indicated by plus point, and the low potential point will be indicated by the minus point. So if we want to represent these flow of charges mathematically, so we can represent it by dq by dt, where dq by dt uh, or we're representing the rate of flow of charges with respect to time. So here I can be represented as dq by dt, and say if we can say that 1 coulomb of charges flowing through a conductor in 1 second, then the total amount of current flowing through the conductor is labeled as 1 ampere. So ampere is the unit for measurement of electric current. So current is represented in amperes, and in other words, we can also reframe this mathematical relationship as I is equals to V by R. This law has been represented as Ohm's law, and we will discuss it in later classes. But we can refine the definition of 1 ampere, that if 1 volt of potential applied across a conductor having 1 ohm resistance, then 1 ampere of current would flow through that conductor. Discuss the next fundamental quantity of electric system is the EMF. EMF is basically uh, called as electromotive force. So as we know, as we discussed in the part of electric current, that the charges are flowing from one to another point. Okay, and these flow of charges is possible due to the potential difference. So we can say uh, whenever we are doing some work, there will be a force which is offered on us. That's why we are doing some work. We can say we are eating food because we are hungry. In the same manner, if the charges wants to flow from one to another point, a force will work on it. Okay, that force is called electromotive force. This force offered on a charge, and that's why the charge is capable to move from one point to other point. So we can say it is the driving influence which is um, offered on the charge, so that it can start its traveling in a conductive path. So EMF is nothing but the electromotive force by which the flow of charges through a conductor could become possible, or the flow of electric current in a closed path will become possible. Voltage is the work done. Uh, so whenever we applied an EMF across a conductor, or whenever we applied a voltage across a conductor, the charges will start to flow from high potential to low potential, and during this flow of charge, work done has been carried out through the conductor. So basically, voltage is nothing but if we want to represent it mathematically, then it will be work done by the flow of charges. So it can be represented as dW by dQ. So if we say that 1 joule of work has been carried out by 1 coulomb of charges, then we can say 1 volt of EMF or voltage is utilized to do this work. So volt is the unit to measure voltage. The next fundamental term is power. So basically, the rate of doing work is called power. So the power can be divided into two category according to the uh, nature of the supply. If the supply is DC supply is the direct current, that is the supply in which the magnitude of the electricity is constant. So the power can be represented by the product of applied voltage and circuit current, or we can represent it as square of circuit current multiplied by the circuit resistance. Or the AC power, basically AC is the electricity whose nature is varying with respect to time. At each instant of time, we get different magnitude of the magnitude in the AC waveform. So when we trace the AC waveform, it will seem like a sinusoidal waveform. So generally, the AC electricity is represented by the sinusoidal sinusoidal form, and in that case, the power which is actually utilized to do work can be represented by the product of applied voltage, circuit current, and the cosine angle between these voltage and current. And now we will discuss about the load, what kind of load we can connect across the supply. So basically, it can be categorized into two categories. One is the resistive load. So basically, resistive load is like the most common example for resistive load is the electric bulb, which has a resistive element only in its circuitry. And reactive load is generally the inductive load, which is made of the coil, like the electric fan. The unit to measure power is watt or in the horsepower, but generally the electric unit for the measurement of power is watt, and the meter which is used to measure electric power is the watt meter. Now we will discuss about the basic law of electricity, that is called Ohm's law. Uh, Ohm's law states that whenever we have applied a potential difference across a conductor, then this potential difference will directly proportional to the current flowing through the conductor. Now, this proportionality constant, this proportional sign can be replaced by a constant, and this constant is called resistance of the conductor. So basically, resistance is the property by the virtue of which any conducting material opposes the flow of current through its body. And this property is called resistance, represented by capital R and measured in ohms. So this is all about the fundamentals of electricity. So basically, in this presentation, we have discussed uh, a brief about the structure of electrical system and some fundamental quantities like charges, current, voltage, EMF, Ohm's law, power, and resistance. So that's all for today, and thank you so much for listening.